Alright, today we're going to look at the ND2 past question on calculus. So if you're in ND2, this video is going to be helpful, or if you're just taking a calculus exam, this might also be helpful. So we're going to go through the questions one after the other, but I'm starting from question number 1, and then we're going to progress. It says we should differentiate the following using first principle. So you see, we can use any method of our choice. We can use any method, but this question is limiting us only to the first principle. So let's just go straight to business. Now, what you need to remember from the first principle is that the limit, this is how we state it, the limit as h approaches 0 of f of x plus h minus f of x, divided by h. So you just need to know this. Now, I'm not trying to build any concept around this, because that's what I really do. I like to build concepts, so you're going to have better understanding. But this is just like a crash course, right? I'm just going straight and I'm going to solve, but I'm going to guide you on how you can solve it, just in case you see this type of question. Now, seeing that in the relation, you see, we have everything as a function. What I mean by function, let's consider this first question, that y is equal to 1 over 3x squared. It simply means that y is a function of x. Better put, it means that what y will be depends on what x is. So I can rewrite it as a function notation. I'm going to say that instead of y, and I'm going to say y is a function of s, and the function is 1 over 3x squared. Okay, just to add more perspective to this, what happens to y when x is 2 is now going to be written as f of 2 is equal to 1 over 3. Instead of x, now we're saying that x is 2. So this will be 2 squared, which is 2 squared is 4, and then 4 times 3 is 12, meaning that when x is 2, y will be 12. Alright, now if you look at this, you see that we need f of x plus h. So in the same manner, we're going to say, since this is f of x, what will be f of x plus h? That is just going to be 1 over 3. The same thing, wherever we see x now, we're going to plug in x plus h, and then is all squared. So we're not going to carry these values and put in the equation. So we write the limit. Now, this is the only thing I don't like about the first principle, is the fact that we need to keep writing the limit as h tends to 0. And there's a reason for that, but I'm not building any concept in this video. I'm just doing a crash course. F of x plus h is 1 over 3 into x plus h all squared, as you can see there, minus f of x. You see our f of x is 1 over 3x squared, and notice that everything is divided by h, right? So I can just write divided by h, here. So all of this divided by h. Now let's make more space there. Again, the limits as h approaches 0. Okay, now we're going to try to have a common denominator. Okay, we want to find the common denominator of these denominators here. We can call it LCM. So notice that we have 3 in common. So 3 is going to be there. We have x squared, and then we have x plus h squared. So this will be our LCM. Now when we divide, notice that 3 will cancel 3, and x plus h squared will cancel x plus h squared, leaving only x squared. And then s squared times 1 is still s squared. So what we're going to have there is what? S squared. So x squared minus, now notice that 3s squared is going to cancel 3s squared here. What we're going to have left is x plus h squared, and times 1 is still x plus h squared. So I have x plus h squared. Good. Now we just need to write our divided by h. Now let me just continue on the same line. We just have to expand. So I'm going to have s squared minus, if you expand x plus h squared, you're going to get h squared. So the limit as h approaches 0. Now we're going to use this negative sign and multiply everything in that bracket. So that's a very important step. It will be minus x squared. The negative will change the plus into xh to be minus 2xh, and then also minus h squared, and divided by 3x squared into x plus h all squared divided by h. Now let me just continue on this line. Notice that s squared is going to cancel x squared there, right? So we can say that s squared will cancel s squared. What we're going to have left is just minus 2xh minus h squared all over 3s squared into x plus h squared. Now changing this division to multiplication, this is going to be 1 over h because actually this is h over 1. Now notice that in the numerator there we have h as a common term. Okay, so you can clearly see we have an h here and we have an h here. So I can factorize, I can bring that h out. So we're now going to have the limits. Okay, I have to write this again. As h approaches 0, I have my h out, and then h dividing minus 2xh will remain minus 2x, and then h dividing h squared is going to just be h. Good. All over everything we have in the denominator there. Now notice that at this point we can now easily cancel the h terms because this h can now cancel this h, which is actually what our goal has been, to eliminate that h from the denominator. So we can now allow h to be 0. Okay, now if I've eliminated that, I can now allow h to go to 0. So I'm now going to have minus 2x minus 0, right? I'm allowing h to be 0 now, divided by 3x squared into x plus, instead of h, I'm allowing h to be 0 all squared. Now, if I put h as 0, I don't need to write the limit again, so I can just solve. Minus 2x minus 0 in the numerator is still going to be minus 2x divided by 3x squared. X plus 0 is still x, so this is just going to reduce to s squared. And then we're going to have minus 2x divided by s squared times s squared is x raised to power 4. And then we can just cancel the x on the numerator and the denominator. Okay, so you see this x will cancel, leaving x raised to power 3. And then that will be our final answer. Our final answer would be minus 2 over 3s raised to the power 3. And then that's just it. So using first principle, we have been able to simplify the first part of question number 1. So we're going to now go on to the second part, which is y equal to 2s squared divided by 2x minus 1. Alright, so this is the next question. Remember, we're still using the first principle, so we'll go over the whole thing again. The limit as h tends to 0, f of x plus h minus f of s all over h. Good. Again, rewrite this in function notation. Our f of x is 2s squared over 2x minus 1. Then our f of x plus h will definitely be 2. Instead of x, we now have x plus h squared over 2s. Instead of x, again we have x plus h minus 1. So everywhere you see s, replace it with x of x plus h. Okay, so now let's just substitute the values. I'm going to assume I'm still on the same line. So instead of f of x plus h, I'm going to replace it with what it is, right? So it is clearly 2 into x plus h squared over 2. Now let me expand this guy. All right, let's expand. So I'm just going to highlight what I'm expanding. It's going to be better, I'm guessing. So when we do 2 times x, we're going to have 2x. Color out, but let's just continue. 2 times h, I'm going to have 2h and then the minus 1 there. Okay, the whole of this is f of x plus h. Now what is f of x? F of x, you can clearly see there is 2s squared over 2x minus 1, and this, the whole of it is divided by this h, so please don't forget the h. Okay, and I like writing it this way, just divided by h. Good. So the limits as h approach 0. What can we do? Okay, let's have a common denominator again. I think this is always the best way. So now the whole of this denominator here is one term. We treat it as one term, and this also is one term. So don't make the mistake of separating them since they are joined by addition and subtraction. So our common denominator is going to be 2x plus 2h minus 1, times 2x minus 1. Good. Remember that we have our divided by h. So what's going to happen now when we divide the first time, this is going to cancel the whole of this, right? So what will be left? 2x minus 1 will be left. So this 2x minus 1 left, we're going to have 2x minus 1 multiplied by this numerator. That is just the way it is done. So multiply by 2 into x plus h, all squared. Wow. And then we have minus. When we divide the next time, you see that this will cancel this, and then this other one will be left. So it's going to be what is left, which is 2x plus 2h minus 1. I think I'm going to require space. Let me get rid of this one. Okay, minus 1 multiplied by what we have there, which is 2s squared, right? Okay, and then divided by h. Wow. So you just have to be comfortable with expansion, factorization, and all that, because this is wide. But let's just continue. Again, we have to write the limit as h approach 0. Now we have a whole lot of expansion. I think I should just separate this because this is one term and this is one term. So we're going to expand as much as possible. How do we start this expansion? Okay, so I'm going to have on the numerator, we have 2x minus 1, and it's going to be multiplied to 2 into. Now let's expand the x plus h squared. All right, let's expand this guy first. Using the identity again, is going to be s squared plus 2xh plus h squared. Good. This is what we have. And then minus. This is easier to expand. So let's just we're going to use this 2x squared. Okay, we're going to use this 2s squared and multiply every term in this bracket. So just follow the process. Okay, so 2s squared times the first one, which is 2x. 2 times 2 is 4. x squared times x is s cubed. Good. 2s squared times 2h. 2 times 2 again is 4. S squared times h, you just have s squared h. That's what we have. And then 2s squared times minus 1 is just minus 2s squared. So I think this one is easier to expand. Don't forget you're divided by h somewhere there, and don't forget that this is all over this nonsense looking denominator. Okay, just be patient enough and follow the process. Okay, so we now have I have to write this again, the limit as h approach 0. Now you can see I can now expand. I think this left side requires much expansion, so I'm going to now expand this bracket. I'm going to say I'm going to use this 2 and multiply every term in this bracket. Okay, so let's do that. What are we going to have? So 2 times x squared is 2s squared. Now let me just put this in a bracket. 2 times 2xh will give you 4xh, and then 2 times h squared will give you 2h squared. Good. Minus the whole of this. Okay, divided by h, and all divided by, to use 2x minus 1 and multiply the whole bracket, and I think that would be it for the expansion. X times 2s squared, you're going to have 4s cubed. 2x times 4xh is going to give you 2 times 4 is 8, and 8s squared h. 2x times the whole of that's 2h squared is going to give you 4xh squared. Good. We've multiplied everything by 2x. Now it's time to multiply everything by minus 1. So minus 2s squared minus 1 times that is going to give me minus 4xh. Minus 1 times is going to give me minus 2h squared. So I've successfully expanded this whole bracket, right? And then notice that this side, everything in this bracket, you're going to multiply with this minus. I hope you can see this minus I'm highlighting here. So multiply anything by minus, the sign is just going to change. That's the only thing. All right. So I'm now going to have minus, now this is going to be very long, minus 4s cubed. Minus 4s cubed. All right. I'm going to go to the other line. Minus 4s squared h. Minus will change the sign of this to plus, then plus 2s squared. And the whole of this, is divided by 2x plus 2h minus 1 into 2x minus 1. And remember, divided by h. Wow. Now it's just time to look out for the things that can cancel. So anything that can cancel, we just cancel it and then we proceed from there. Okay. Now notice that I have 4s cubed minus 4s cubed. So that will cancel to be 0. What else can cancel? I have minus 2s squared and 2s squared is going to cancel. Right? Look out for another thing that can cancel. I don't think any other thing, although I think we have like terms, right? So notice that we have 8s squared h and we have minus 4s squared h. So 8 minus 4 is just 4. So now it's just time to have the limits as h approach 0. We have 8 minus 4, we have 4s squared h. Good. This does not have any like term, does it? 4xh squared. No like term, so I'm just going to write it plus 4xh squared. And then minus 4xh does not have any like term, so minus 4xh. And then minus 2h squared. So we've reduced everything to this. Now this is divided by 2x plus 2h minus 1 into 2x minus 1. I will now change this division to multiplication. This becomes 1 over h. The last time I'm going to write this, the limit as h approach 0. Notice that every term here I have an h, all right? It has an h, so meaning I can factorize. I can now have that common factor of h into divide 4s squared h by h. You're going to have 4s squared plus divide 4x h squared by h. You're going to have 4x h. One of the h is going to cancel. Divide 4s h by h. You're going to have 4x. Divide 2h squared by h. You're going to have 2h. Good. We factor this out and then we have times 1 over h. And I'm making more space there. Again, this is all divided by 2x plus 2h minus 1 into 2x minus 1. Notice that I can now say h cancel h. Wow, this is not difficult, right? But it might be, unnecessarily long. So now that I've cancelled that h, I can now allow h go to 0. So bye to limit as h tends to 0. So I'm now going to have 4s squared plus 4x. Instead of h is now 0. I've allowed it to go to 0. 4x minus 2 into 0. Okay, divided by 2x plus 2 into 0 minus 1. I'm allowing h, all the h to go to 0. This will be equal to, notice the things that will cancel out because here I have 4x times 0. Anything times 0 is 0. So this will cancel, this will cancel, this will cancel. So I'm now going to have my final answer, hopefully, 4s squared minus 4x. That's the only thing I have in the numerator.
English. Itiki taka.
Itiki taka.
What is a piggy?
What is a piggy?
Está giremo.
Está giremo.
Audio.